So today I will tell you something about running mainline Linux on the Motorola Droid 4, which is an Android-based mobile phone from a couple of years ago. But before doing that, let's have a look at other supported phones. So when I started getting interested in kernel development, I had a free one now, which was pretty well supported by Debian, but the kernel never really reached mainline. So when I had a new phone, I started working to get everything mainline, which is the Nokia 900. It's pretty well supported nowadays. Yeah, but it's kind of old. It just has 256 megabytes of memory and it's really slow. So since a year or so, I'm working on the Motorola Droid 4 together with Tony Lindgren. And yeah, we got quite a bit of hardware working on that one. So why are so few mobile phones supported? I think it's a combination of multiple reasons, but most important, the phone vendors don't care. They don't really work on mainline support, so it has to be done by the community. And there's lots of code required to get the phone working. The SOC must work, all the peripherals must be supported, and the code that one can get from the vendors, usually they are vendor Android trees, is really low quality. You can't get those drivers into mainline and have to rewrite them. Also, once you're done, you have the problem that you don't have any user space because nobody wrote it and nobody wants to write it because, well, there's no kernel support. Also, usually it's quite hard to get data sheets, and you have the problem that you need somehow a serial access, because if something fails in the kernel, you want to see what failed and not just get a black screen. So for the N900, this was quite hard to do because the debug access was below the battery. Here there are some pads, so I had to build some adapter to get access to it, which took quite some time. For the Droid 4, it's much simpler because it has the serial pins pin maxed to the USB connector. So you can just use a normal USB cable, cut it, connect it to a standard USB serial adapter, and then you have serial. The only important thing is that you don't attach the 5-volt pin, because then it will mux back to USB mode. Yes, so for the SOC, and the Droid 4 is an OMAP-based processor from Texas Instruments. This is similar to the Nokia 900, which has an OMAP 3. So most of it was already supported when I started working on it, which means that it's possible without doing anything to boot into the kernel and get a serial console. And I didn't do any work on that part. It was already there. Which means there were clock drivers, reset drivers, timer drivers, interrupt drivers. The memory management unit was already supported DMA. All of that needs to be done. I think there's a talk from Enric later. He may tell you a bit about that part. Then the GPIOs were already supported SPI and I2C, so you can directly start working on the, supporting the peripherals. What was not supported is the display, because in this phone Motorola used a self-refreshing display, which is currently not supported by the OMAP DRM driver. I will come to that later. Also unsupported is the camera interface, which nobody worked on so far. And most importantly, there's no graphics acceleration at all. The chip uses...
Can you move your microphone like here or on the other side, because you're always talking like this and the microphone...
Right.
And there goes the rubber thingy.
But we will put that back later on. All right. So, right, the graphics. Yeah, the OMAP and all of them have PowerVR-based graphics chip. So there's no open source driver for that one. And apparently, even the closed source drivers currently not working with the current mainline kernel. So far, I didn't care at all because there's so much other work to do. Yes. The power management chip is a different matter. Usually, the Texas Instruments chips are used with well, a companion chip from Texas Instruments, but Motorola decided against this and used their own, which is named Motorola CP Cap. And after some reading of their drivers, we noticed that it's really similar to a chip from NXP, which is named MC13783, and has a public data sheet, which is quite nice. Especially since all of the drivers from Motorola are really low quality. So we started rewriting all of them and currently finished the regulators drivers, the analog digital converters, the battery and charging drivers, the real-time clock and the status LEDs, which is almost all of the supported features of the PMIC. Still missing though is the audio support, which is work in progress. Here. Additionally, there are quite a lot of peripherals attached to a phone, obviously. The nice thing is that nowadays on the mainline kernel, almost all of those already had drivers because somebody required them for some other boards or chips. So we could just enable those in the device tree, which is the touchscreen and the keyboard, the buttons, the vibrator needed a custom driver, which is just like 150 lines of code. It's connected to a PWM output. And right, the phone has HDMI output. Difference to the display, that one is working because it does not need any self-refreshing feature, and it's basically exactly the same as on the Panda board, which is well supported by the mainline kernel. Right, not supported, as I told you, is the LCD panel. Basically, it's just a couple of lines missing in the mainline kernel because the display self-refreshes. So you just send it a picture one time when the display changes, and then again when the display changes next. This is currently not supported. There are patches on the mailing list. I hope that they will arrive on the next kernel release. And also, it will only work with Xorg and with the normal shell. It won't work with Wayland because Wayland currently has no support for telling the kernel that the frame buffer changed. In addition to the LCD panel, the backlight controller is currently unsupported. We know which one it is, and we have patches for it, but they have not yet arrived mainline, and there's some discussion going on about the device tree bindings, so it will take some more time. But once those two have arrived, we have full display support. Right, and those are the more important peripherals, I guess. The more unimportant ones are already working, or the sensors. They had drivers on the kernel, so we just had to enable them. So let's move to the more interesting parts, how to connect to the internet. The phone has a Texas Instruments-based Wi-Fi solution, which worked from the start on because there were drivers available. And since, I think, 2 kernel releases, we also have Bluetooth support. Not yet working is the included FM receiver, but that one is also not supported by Android, so I guess it's not that bad. Then the interesting part, the phone actually has 2 different modems, one for 2nd and 3rd generation and one for the 4th generation's networks. Unfortunately, the 4th generation networks is only supported in the US because the modem is limited to their frequencies. Also, that one is currently not working. I didn't have a look at it because I'm based in Europe, so I don't care, basically. But the 2nd and 3rd generation is working pretty well. And Tony Lindgren is based in the US, so he's currently working on the 4th generation modem. We currently know that the main problem is that it tries to access the SIM card from the other modem using some weird protocol that is currently not supported. Here, for the normal modem, we basically have GPS working and data connections, and we can send short messages. We can't do voice calls yet because audio is missing, so nobody really tried. Yes, we also had a short look at the camera stuff. The problem here is for all the other peripherals, we could have a look at the kernel implementation of Motorola and just rewrite their drivers properly, but we could use their drivers as documentation. This is different for the cameras because the OMA 4 has a small processor inside of it which can handle all the camera stuff. It's the one marked, oh, here you can't really read it. Anyways, there's a small companion processor, and Motorola does all the camera work on that one. And the firmware for this processor is closed, so it's hard to understand what is going on. We know the LED flash chip just by well, trying to check the registers, reading their values, and comparing it to datasheets that are public. So we pretty well know that it's an LM3559. Because the reset state of all the registers is exactly the same. And we assume that the main camera and the selfie camera are those chips listed here. We don't know for sure because we have not yet managed to speak with those chips at all with the mainline kernel so far. So there's lots of work to be done here. Yes, so I'm mostly a kernel developer. I can't tell you many things about the user space. What I can tell you is that there are two different implementations which act as an interface to the modem that abstract away different vendor implementations. One of them is the freesmartphone.org stack, which is more or less abandoned upstreamed. Last change has been, I think, 3 years ago. And there's Ophono, which only abstracts away the modem. So Ophono in FSO does an abstraction layer for all the peripherals, not just the modem. Ophono concentrates on the modem, but it's still supported upstream. The last change is probably from yesterday or so. And it does support the Motorola. So that one can be used. Another option would be to use Android. I can't tell you anything about it, but later there's a talk from Robert Voss downstairs. It's directly after this talk. He can tell you something about this. And of course, you can run a normal Linux distribution. That's what I'm currently doing. It will only be useful on the Droid 4 and not on other mobile phones. So if you plan to do something similar on those, you will have the problem that they don't have a physical keyboard, which is one of the nice features of the Droid 4. And there are a couple of special operating systems, like the stable hit rate release. That one was distribution for the FSO stack, so it's also dead, obviously. Then there's Firefox OS, which is no longer continued. We have Sailfish OS, which is not yet fully open source. We have Tizen. To be honest, I have no clue what the current state of Tizen is. And then we have Purism, but they are not yet finished with their development. We have Postmarket OS. It's also currently in development. They are sending me questions from time to time how to support the Droid 4 or the Nokia stuff. And we have Memo Liste. They apparently sent me a nice screenshot of their current state on the Droid 4. So some people may remember Memo from N900, which is like 8 years old now. And here it's still living. So let's come to the conclusion. I think it's an interesting topic to get into kernel development because you have to touch basically all the subsystems and get in contact with everyone. And you learn about a lot of different hardware. Also, if anyone is working on similar projects, every driver helps. So if you support something, it may help somebody else. For example, well, if you have some temperature chip, it might be built into some phone, and then somebody else can just enable it. This was really helpful. Yes, so the big hurdles on the Droid 4 are 3D acceleration. To be honest, I'm not sure that we will ever get it working because it's basically all the work that we did so far multiple times. Then the camera support, because we don't have documentation and it's really hard to do reverse engineering on that one. And last but not least, proper user space. As I told you, I'm a kernel developer, so this is not my department. So So let's try it out. Oh. So I've attached the Droid 4 to my notebook. So at some point HDMI will enable. Then we will see the kernel booting. At the moment the display is rotated. This is because I did it in the command line. The reason for that is that currently we have the problem that the internal display is rotated, and we just rotate it by command line, and that will rotate the shell both on the internal display and on HDMI. Oh wow. I guess we can skip that one. Yeah, there's something, but the beamer is not good enough. Sorry.
There's the password.
Yes, it's the login prompt from a Debian. Well. Yeah, I plan to show you a couple of things, but I guess we can skip that. The display is too bad. So, yeah, don't go to the start. Are there any questions?
I guess you not. Sorry.
What's the state of the power management in the kernel for the device? So does the suspend current go down enough?
So suspend does work, but at the moment we don't really use it. There's about 6 to 7 hours we can use the phone by just running it without proper power management, which was good enough for us so far.
Have you looked into the bootloader side, especially U-boots? And do you know if the version of the OMAP stock that's used on the phone is the high security version that's fine and that you cannot run your own first bootloader on? Or is it the general purpose version where you can actually do that? So are there signing keys and is it locked?
So yeah, it's the high secure version of the OMAP, and the bootloader is locked. Apparently we managed to boot it anyways. That is something that the lineageRes people did. They boot via kexec, and we do the same. We are currently trying out to boot differently because you can apply custom kernel parameters to the kernel used by Android, and so you can skip some parts. But at the moment we use exactly the same system that the lineageRes people use.
Out of interest, how is the keyboard connected internally? Which is the interface to the keyboard?
The OMAP processor has a matrix where you can connect a keyboard to.
The modems, are they on USB? Both?
Yes, both modems are connected to USB.
So they don't have direct memory access?
Exactly.
You mentioned the main problem was a lack of a proper user space, and then you listed a bunch of projects there, and you said a few others that I'm aware of. What would you consider to be a proper user space?
Well, I think
Hairy question.
it is, because so for me it's enough to just run Debian on it. I'm fine with that, but I see that most people want something where they can use the touchscreen properly and stuff like that, and most of those projects are either no longer being worked on or are not yet ready to be used. So I guess one of those projects may be fitting for that task.
Yeah, I mean, a bunch of touches still being worked on by the community, even though it was dropped by Canonical. The KDE guys are still plugging away at last month. There's WebOS guys doing Lunos, so I mean, there's a few around.
Here.
One other thing is that recently we got the Power VR stuff to work on the 900, so I think with the most recent TI releases it might not be too far out for the Droid as well. The only real trouble will be getting the actual Power VR main stuff merged in Mainline. Because now it's out of patches, but I won't accept it because there's only a closed user space driver.
Yes.
So you can never accept that, so
Yes.
that's another hurdle.
So it will definitely not be merged, that's obvious. Yes.
With
the camera and the companion chip, is there any signs that you could reprogram the firmware running on the companion chip from the main processor?
So I have not yet tried to work with the second processor on the phone. Technically, you are not required to do so. So I did manage to enable the flashlight for the camera by just talking to the chip directly. It's connected via I2C. What the Android-based kernel does is that it takes the I2C interface and tells the second processor, here, this is the I2C interface, do what you want with it, I won't touch it. So in the mainline kernel, we have not really touched the second processor, so I can just use the I2C channel and just talk to the chips myself. The problem is that I have to enable them first, and I have to know how to enable them. So for the flashlight chip, we managed to find out how to enable it. For the camera chips, we did not yet find out. So if we scan the bus, we won't find the chips. Any more questions? Yes.
OMAP 4 camera interface different than that one from OMAP 3?
Yes, it is different. For OMAP 3, the camera interface is properly supported by the mainline kernel. For OMAP 4, there are drivers and staging. I have not yet looked at them because we cannot talk to the camera chips themselves at the moment. So the camera interface is only useful once you can enable the data on the chip.
The OMAP 3 camera and mainline, it's not that good.
Yes, but it's working. So on the N900 we got pictures from the camera with the mainline kernel.
If you do not do something to create here and then, I've seen a lot of kernel hangs these days because of that driver doing something weird. That's a good, nice place to debug.
All right. So I'm finished.